Okay, geometry fans, our topic for today is we're going to talk about the area and circumference of circles. Now, we're not going to worry about the three-dimensional stuff. We'll do that on another day. So today, area, circumference of circles. So let me start with our joke of the day. And the question is, what time is it when you have to go to the dentist? And the answer is 2:30. Tooth hurty. Okay, there we go. I got to admit that's actually pretty bad compared to my other ones. All right, so area, circumference of circles. There are two formulas that we're going to use for this. Two formulas we're going to talk about today. The first one is called circumference. Circumference is basically the distance around a circle. Distance around a circle. You might say perimeter, except perimeters you add up the sides, and a circle doesn't have sides. So circumference is the distance around a circle. The other way we talk about it is arc length. Arc length, the length of the arc as you go around. Okay, now there's actually two formulas for this. Circumference is pi times diameter, and pi is approximately 3.14. If you're going to use a decimal for that. So circumference is pi times diameter. Now, since diameter is really two radii, we can also write it circumference is 2 pi times the radius. That's the one we're going to use more often. That's the one you'll see me use. And the reason I'm going to use that is because the area formula, now area is the amount of covering of something. We'll say amount covering. The formula for area is pi times radius squared, pi r squared. So circumference is 2 pi times the radius, area is pi times the radius squared. Okay, so those are the two formulas we're going to be dealing with today. And a lot of this will be on the calculator that you can use. Number one, let's look at some examples. Find the circumference and area of the circle. All right, well, we need the radius. We've got it, 9 centimeters. There's our r. So circumference is 2 pi times the radius, which is, in this case, 9. Now, there's actually two ways you can write your answer. If we just do 2 times 9, we get 18 pi centimeters. This is a good answer. This is what we call the exact solution. Now, if you use the calculator, okay, if I want to type 18 pi, now there's actually a pi key on the calculator. If you look at the exponent key right here, where you raise something to a power, there's a little pi button in blue right above it. So if I hit second and that symbol there, I got 18 pi. Now on the calculator it gives me a decimal, 56.54, so on and so on and so on. I'm going to round that to 56.5. So you could say it's 18 pi centimeters or 56.5 centimeters. Both of these answers are good. The first one, 18 pi, is what we call the exact solution. And then the second one, the decimal, 56.5, is what we call the rounded solution. And in most cases, both of them are fine. Okay, you can use either one. If you're trying to be exact, you'd use the pi, leave it in terms of pi, but most times a decimal is okay as well. So that's circumference. Area is pi times radius squared. Now the radius is 9, so I would do 9 squared, which is 81 pi. Now this is an area, so 81 pi, or on the calculator, 81 times pi equals, we would round that to 254.5. 81 pi, or 254.5. Now when you talk about area, it's the unit of measurement squared. It's centimeters squared. because it's two-dimensional, it's the amount of covering. If I were going to fill this circle up here and cover it, it would be 254.5 square centimeters. Okay, so there's circumference, there's area. Let's take the second problem, find the circumference and area of the circle. Okay, same thing. Now this time though, what they give us, 26, is the diameter. So the radius would just be half. So radius is 13. So circumference is 2 pi times 13, which is 26 pi. And 26 pi is a decimal, is 81.7. Area is pi r squared, so pi times 13 to the second power, pi times 13 to the second. Now 13 squared is 169, so we have 169 pi, or that would be 530.9. So 530.9. Now let's see, the circumference is inches. That's the distance around the circle. The amount of covering is inches squared, inches to the second. Okay, so area is always square units, and then circumference is always whatever the unit is. So there's our circumference, and there's our area. So those are the two formulas that we're using. That's basically what we're doing today. Now, we're going to talk about one other situation here. What if you're not looking at the whole circle? What if you're only looking at, say, a portion of it? What fraction of the circle is being shaded? This is question 3. Now, we've got 6 different examples that we're going to do here. What fraction of the circle is being shaded? Now, the first one here, part A, you might be able to just eyeball this and kind of figure out, okay, the shaded area, this is really one of 4 sections. So you could say this is 1/4. So you could eyeball it and you could get it and it would be right. Now, how would we do this mathematically? Well, what you do is you look at the central angle measure. The central angle is 90. Okay, so let's write down that's the central angle. To find the fraction that's being shaded, okay, shaded fraction is we take whatever the central angle is, and divide by 360. Because the total central angle measure of a circle is always 360 degrees. So take that, divide by 360. So for example, in part A, this is 90, divide by 360, and then we just reduce the fraction. Now you can do this, if I do 90 divided by 360, I get 0.25. But I can change that back to a fraction. I can go math, and then number 1 is frac, enter, enter, and I get 1/4. So there's my 1/4 when I reduce it. So some of these you might be able to eyeball it, but most of them I would just take the central angle measure, divide by 360, and that's the fraction being shaded. So part B, the central angle is 60, so let's do 60 over the total central angle measure is 360, and that's going to reduce to 1/6. That's the fraction of the circle being shaded. All right, now what you should do, go ahead and pause this and see if you can get the next 4 examples. Okay, and then when you unpause it, I'm going to work this out. So we'll have 135 divided by 360. If I reduce that by hand, I can divide each of these by 45. And what I get is 3/8. That's my fraction. And now, if you don't recognize 45 as a factor of those, you can do 135 divided by 360. There's my decimal. Math, enter, enter. 3/8. Part D. Now let's see, the 90 degrees is here, but actually it's the rest of the circle that's being shaded. So the shaded part is not 90, it's 360 minus 90, which is 270 degrees. So this is 270 degrees. So the fraction shaded, I take the central angle measure, 270, divide by the total central angle measure of a circle, 360, and what happens, I can cross out the zeros, I can divide by 10, and 27 divided by 36, 9 goes into both of those, and I get 3/4. So the fraction shaded is 3/4. All right, part E. Let's see, so 60 is the central angle, but what I want is everything else. That's where the shaded part is. That's going to be 300, because it's 360 minus 60 is 300. So the fraction is 300 over, divided by 360. I'm going to cross out the zeros again to reduce. Divide by 10, so I get 30/36. Divide each of those by 6, and we get 5/6. So the fraction being shaded is 5/6. And the last one here, okay, we got 135 again, but this time we want the other part of the circle. So all the central angles are 360 together, so subtract the 135, and that gives me 225. That's for the shaded part. So the fraction is 225 divided by 360. I'm going to divide each of those by 45, and what we get is 5/8. So 5/8 of the circle is being shaded. Okay, so all you do is you just take, you want to find the shaded section, take the central angle, divide by 360 degrees. And that's the end of part 1, so go ahead and move on to part 2.